In this question, it says, without graphing, determine whether the graph of a quadratic function opens up or down. We have the function f of x equals x squared plus 7. Now, in the directions, it says to determine if the quadratic function opens up or down. And what that's referring to is that a parabola can look like this or like this. Actually, there are other ways a parabola can look, but only parabolas that are functions can be up or down. Looking at the function f of x equals x squared plus 7, we're going to be able to determine which one of these up or down based on the value of a. So what I mean by that is that the general form of a quadratic function is f of x equals ax squared plus bx plus c. And we call a this coefficient of the x squared term. In the example that we're looking at, a would be equal to 1. Since we don't see a coefficient there, we assume it to be a 1. Now, whenever a is greater than 0 or positive, that means that we have one of the parabolas that opens up. And whenever a is less than 0 or negative, the parabola will open down. So since a is equal to 1 for our quadratic function, we know that this is a quadratic function that opens up. A is 1, which is positive, and that graph will open up. On this question, we want to give the rule that describes the piecewise defined function in the graph below. So we can see that in this graph we have one line and then a second line here. So it looks like we've got two pieces of a graph that we're going to join together. So with a piecewise defined function, we draw it with curly braces, and this one is going to have two equations, and those two equations are going to match the two pieces of the line that we have. And then next to the equation, we have the conditions, and the conditions will tell us when to use each of those equations. So let's call this one equation 1 and this one equation 2. I'll use this graph, this line, to find equation 1 and this one to find equation 2. So let's work on equation 1 for now. As I look at this graph, it is a straight line, and I know how to find the equation of the line as long as I have 2 points on the line. So I'm looking here and I have 1 point marked as -8, -5, and then I don't have another ordered pair. Maybe I do. If I look at this ordered pair, it looks like -1, 2, so they've labeled it. It's just not very close to the point. So I do have a second point, -1, 2. And because I know 2 points on the line, I'm going to be able to find the equation of the line. I'm going to use the slope formula, y2 minus y1 over x2 minus x1. I'll let the first point be x1, y1, and the second point x2, y2. So substituting those values into the formula, I'll have 2 minus -5 over -1 minus -8. In the numerator, those double negatives will turn to positive, so I have 2 plus 5. And in the denominator, the same thing, the double negatives turn to positive. negative 1 plus 8. And I have 7 over 7, which is 1. So the slope of this line is a 1. And now I can find the equation of the line using point slope form. That's y minus y1 equals m times x minus x1. In order to use this form, I need the slope, which I've just calculated, and I need x1, y1, which is a point on the line, and you can use either of the points that we used earlier. In fact, you can use any point on the line. It doesn't even have to be the ones that we have here. It can be any point that you see on this line. So I'll use negative 8, negative 5. It's y minus negative 5 equals 1 times x minus negative 8. And that simplifies to be y plus 5 equals x plus 8. And I want to write this equation in slope-intercept form so that I have y equals. So I'm going to subtract 5 to get y equals x plus 3. And that is the equation that we're going to put for our piecewise defined function. Now, you guys know that a line is never ending, so the equation y equals x plus 3 is actually the full line that I've just drawn. We only want a piece of that line. And that's where the second part comes into play with the conditions. We only want to use a piece of this line. The piece that we see here, let me erase my marking so we can see it a little bit better. We want to use this piece of the line, and the piece of the line begins at this value here of x equals negative 8, and it ends at this value here where x equals negative 1. So I want my x values to be in between negative 8 and negative 1. You'll notice the endpoints on these lines are filled in dots, and that's why when I put my conditions here, I use the equal to. Let me write this a little bit bigger so you can see it better. X is in between negative 8 and negative 1, and with these equal to's here, I've included the endpoints of that line. So I found the first equation and the conditions for that first equation. I want to find the second equation as well as the conditions for the second equation. Now the second equation, I'm seeing it's a horizontal line, and I know horizontal lines have the equation y equals b. So all I need for this is to determine what that value of b is. I notice that this equation has an endpoint of negative 1, 3. 3 is the value of b. So the equation of this horizontal line is y equals 3. So that's the equation that goes in the second spot there. And then I need to figure out the conditions. I erase some of these markings. And I'm noticing that this line starts at an x of negative 1, and because of this arrow, continues on to positive infinity. So this is all numbers that are greater than negative 1. This time, I hope you'll notice that I didn't put an equal to, and that's because the endpoint has an open circle, and that endpoint is not included in the graph or on the function. And so I don't want to include negative 1, and don't put the equal to underneath my inequality symbol. So just to finalize this, we have found that the piecewise defined function is f of x equals x plus 3 for all x that is in between negative 8 and negative 1, including the endpoints, and 3 when x is greater than negative 1. For this question, we're going to let f of x equal square root of x minus 2 and g of x equal x squared minus x. We want to find and simplify the expression. The expression we want to find and simplify is f plus g of 11. There are two different approaches that we can take for this example, and I'll show you both of them. On the first approach, we would start off by building the function that is described here. So we would want to build the function f plus g of x. And once we've built that function, then we'll be able to substitute the value of 11 into it. The way that you build this function is described in the name. The name is f plus g, and we're going to find that function or build that function by adding the function f to the function g. So f plus g of x means f of x plus g of x. So f of x is the square root of x minus 2. G of x is x squared minus x. So now we have the function f plus g of x. Once we have that function, we're going to evaluate. We want to find f plus g of 11. So we're going to substitute the 11 in for these values of x's in the function. That's square root of 11 minus 2 plus 11 squared minus 11. Square root of 11 minus 2 is square root of 9. 11 squared is 121. Square root of 9 is 3. 121 minus 11 would be 110. And 3 plus 110 would be 113. So we found f plus g of 11 to be 113. So this is one approach for finding f plus g of 11. Let me show you another approach. In this other approach, we start with f plus g of 11. This is the second approach. And what we're going to do is substitute this 11 into each individual function and then do the operation that is mentioned here. That's f of 11 plus g of 11. F of 11 is substituting 11 into the function called f. That's square root of 11 minus 2. G of 11 is substituting 11 into the function called g. So 11 squared minus 11. And then we want to add those answers together. Square root of 11 minus 2, that's square root of 9. 11 squared is 121. 121 minus 11 would be 110. Square root of 9 is 3. So we found f of 11 to be 3, g of 11 to be 110, and then we add those results together. I'm adding them together because that's the operation indicated here. And we get 113. So that's two different ways that you could have evaluated f plus g of 11. In this question, we want to find the function g composed with h and simplify. We're given g of x equal to 4 over x plus 1 and h of x equal to the square root of x plus 8. And we want to find g composed with h of x. Now this operation, I called it compose. It's the operation of composition. And the meaning of this operation is to substitute one function inside of another function. So what that means symbolically is that h of x gets substituted inside of g of x. Whichever function is listed first is the outer function, and whichever function is listed second is the inner function. So we want to substitute h of x, this h of x that was given to us, in for x. So that would look like 4 over square root of x plus 8 plus 1. So we found that g composed with h of x is 4 over square root of x plus 8 plus 1. So this format is correct. There is one other thing we could do to it. There's something called rationalizing the denominator, and that format would leave this fraction with no radical in the denominator, but it's not necessary in this simplification. We can leave it just like this. Thank you for checking out my videos. Have a great day.